Sequences, Lesson 2 series. So this time we're going to focus on geometric series. A geometric series is the expression for the sum of the terms of a geometric sequence. The sum of a geometric series can be determined using the following formula, where P1 is the first term in the series, n is again the number of terms, r is your common ratio, and Sn is the sum of the first n terms. Example 1. Determine the sum of the first 10 terms of each geometric series. And the first one is 4, 12, 36. So in this question, T1 is our first term, which is 4. R, our common ratio, is what do I need to multiply 4 by to get to 12? Well, I need to multiply by 3. And our number of terms is 10. The sum formula is that Sn equals T1 times r to the n minus 1 all over r minus 1. So substituting into our formula, T1 is 4 times r, which is 3, to the n, which is 10, minus 1, all over r, again is 3, subtract 1. So using our calculators to help us evaluate, 3 to the 10 minus 1 works out to be 59,048, all over 3 minus 1, which is 2. You can do some simplifying because 2 goes into 4 twice. So then 2 times 59,048 is 118,096. So there's our sum of those first 10 terms. Second example, same idea. So substituting into our Sn formula, T1 is 5 times r, which is 1/2. To the n, we've said that we're doing the first 10 terms again, minus 1. Sorry, I need some brackets in here. All over r, which is 1/2 minus 1. So in the top, we end up with 5 times 1/2 to the power of 10 works out to 1 over 1,024. Subtract 1. All over 1/2 minus 1 is negative 1/2. So this gives us 5 times, I do 1 over 1,024 minus 1, I end up with negative 1,023 over 1,024. If I'm dividing by 1/2, I can also write it like this, by negative 1/2, which means we can flip that and multiply. So we end up with 5 times negative 1,023 over 1,024 times negative 2 over 1. Five times negative 2 is negative 10 times negative 1,023 over 1,024. Multiplying that out, we end up with 5,115 over 512. So this is our sum. We want to keep those sums as fractions so that we have exact sums rather than approximate answers. Our next example is determine the sum of a geometric series for an unspecified number of terms. So this time we don't know what term this last one is, but we know that it's equal to 729. So we know that T1 is again our first term, in this case 1 over 27. We know that Tn is 729, and we can find r by dividing this term by the one before it. So r can be found by doing 1/9 divided by 1/27. So So R is 3. Right? Flip the 27. 27 over 9 is 3. So substituting in to find our m value, we're going to substitute in this time just into our Tn equation. So remember that Tn is equal to T1 times R to the n minus 1. I have to have my m value before I can find the sum. So Tn, we know, is 729. T1 is 1 over 27. R is 3 to the n minus 1. You can multiply both sides by 27 to get rid of the denominator, and I end up with 19,683 equals 3 to the n minus 1. We now need to find out 3 to what power is equal to 19,683. So to solve this question, I need to figure out what power of 3 that is equal to. We're going to do it by trial and error, and we actually find that 19,683 is equal to 3 to the power of 9. So if I get rid of this for a minute, let's back up. This side, the left side, is equivalent to 3 to the power of 9. So I know 3 to the power of 9 is equal to 3 to the n minus 1. If this is true, it means that my exponents must be the same because my bases are the same. So that means that 9 has to be equal to n minus 1. Solving for n, I end up with n being equal to 10 terms. Now that I've found the value of n, I can now use my sum formula to find the sum. So to find the sum, we're going to use our Sn formula. So Sn is equal to T1, which in our case is 1 over 27, times R, which is 3 to the power of 10, minus 1, all over R minus 1, so 3 minus 1. So we just substituted our values into that Sn formula. Simplifying this formula, we end up with 1 over 27 times 3 to the 10 minus 1 works out to 59,048, all over 2. If we're dividing by 2, it's the same thing as multiplying by 1/2. So I can rewrite this to be 1 over 27 times 59,048. Again, dividing by 2 is the same thing as multiplying by 1/2. Simplifying that gives me 59,048 all over 54. And again, I can simplify that fraction and end up with my sum being 29,524 all over 27. We're going to save some time and we're going to skip over example B. Example 3. This is an application problem. It says using a geometric series to model and solve a problem. A doctor prescribes 200 milligrams of medication on the first day of a treatment. The dosage is reduced by 1/2 on each successive day for 1 week. What is the total amount of medication prescribed to the nearest milligram? So on the first day, so T1 is going to be 200 milligrams. If it's reduced by 1/2, that means that our R value is 1/2. And if we're reducing it every day for a week, means we're going to reduce it 7 times. So our Sn equation, I'm just going to rewrite it so that we don't forget what it was. And now we can substitute in. So we end up with Sn is equal to 200 times r, which is 1/2 to the power of 7, minus 1, all over 1/2 minus 1. Simplifying a little bit, this gives us that 200 times 1/2 to the power of 7 is 1 over 128 minus 1. All over 1/2 minus 1 is negative 1/2. Simplifying the top is 200 times 1 over 128 minus 1 is negative 127 over 128. If I'm dividing by 1/2, it's the same thing as multiplying by negative 2, because I'm dividing by negative 1/2. At this point, we can simplify things out. This first part works out to negative 3,175 over 16. Multiplying by negative 2 gives us an answer of 3,175 over 8. If I divide that out, because I'm asked to do it to the nearest milligram, I end up with 397 milligrams. This is the total amount of medication needed.